All right, so just to recap for the people who just got here, some people chose A as not belonging because it was the only one with a greater than. Nobody had chosen B, although you could have. For C, we had a number outside the absolute value that you have to get rid of first, so some people chose C for that reason. And then for D, some people chose D because it was the only one with an equal to sign, which would have given you that filled in dot. All right, so we're on mystery equation. Before we can try to solve these backwards, notice these are problems where I give you the answers and you're trying to come up with a question. I'm going to do a problem forwards for you because I want you to think about how it's going to work in one direction before the other direction. It's been a little while since we've done an absolute value equation. This is not for you to do on your paper, it's just for us to think through together. So if my equation is absolute value of x minus 8 equals 5, do I have the absolute value by itself already? Yeah, so I don't have to get rid of anything else. I do have to write it twice. X minus 8 equals 5, and x minus 8 equals what? Negative 5. Good. And then I solve them both. And I'm going to get x equals 13 and x equals 3. Two solutions. Okay? So then what we're doing is we know that the solutions are 8 and 2. We're trying to come up with the equation. It's going to be absolute value. There's a hint that there is a subtraction in the equation. So the reason I gave you guys markers is so that on your desks you could try out a few things before you actually commit to putting something on your paper. So on your desk, you're probably going to start with an absolute value and an x. And since the hint said there was a minus, I would put in a minus. And you're going to try a few things to see if you can come up with an equation that's going to give you the solutions 2 and 8. So take a few minutes to do that. All right, so I'm going to first show you a wrong answer because we can learn a lot from wrong answers too. This is on my sticky note, which means don't put this on your paper, okay? The sticky note is just my little thinking space. I saw this wrong answer from a few of you, which was x minus 2 equals 6. Now, why is this a good wrong answer? What is this student doing well? It gives 8, right? So a student who wrote this down, and it was more than one student, realized that this number plus this number has to be 8, right? Plus 2, x equals 8. And then you would check the other answer, x minus 2 equals negative 6. And it gives negative 4. And so then you realize, okay, it's not that, but I'm on the right track because I had to find two numbers that add up to 8. So raise your hand if you did find one that did work. I see 2 hands, 3 hands. AJ, what did you find that worked? The one I showed you? I didn't show you an answer. Did you find one that worked? Okay, sorry. I thought you found one. Amar? You got the same one, Osman? Okay. Absolute value, x minus 5 equals what? Equals 3. All right. Does anybody else think this one's going to work? Raise your hand if this one looks good to you. Okay. Now, this one is an answer, and I'm going to put it in a box. The equation is the answer. But the check is going to show us that it works. So let's do the check right now. The check is to solve it. So one of them is x minus 5 equals 3 with no absolute value. X minus 5 equals negative 3. So this one is going to give us 8. And this one gives us 2, right? All right, so that was our check, but our answer is the absolute value equation. So you guys were supposed to come up with the equation. Now, as you know, in math class, we don't only learn how to solve problems with guess and check, right? Like we actually learn procedures for solving problems. However, Knowing how to check your answer is important because that way, if you write something down and you're like, I don't know if I did it right, well, now you know how to check it and see if you did it right. Okay, so think back to last class. Last class, we learned a way to solve word problems, and it involved the center and the distance. Let's look at this equation here. How is 5 related to my endpoints 2 and 8? How is 5 related to 2 and 8? It's in the middle. You see that? So 5 is the number that's in the middle of 2 and 8. It's the center. Where do you see a 3 in this graph? If I'm looking at 2, 5, and 8, those are my 3 numbers, and 5 is the center. Where do you see a 3? It's between what? Between 2 and 5? Could it also be between 5 and 8? Let's count. 1, 2, 3. So between 2 and 5 is good. What about between 5 and 8? 1, 2, 3. Yeah, it works both sides, right? So 5 is in the middle. It's 3 away from 2. It's 3 away from 8. So this is what we're going to use. We're going to use the same equation from last class, which was this one. The absolute value of x minus the center is equal to the distance from the center. Okay? So you see, if we can use this equation, we don't have to guess and check our way there, right? We can actually figure it out right away. So look at the next one. The solutions are -1 and -17. So you're going to think about what is the center and then what is the distance from center, and you're going to try to write this equation. It's a little bit harder just because the numbers are negative and they're bigger numbers. They're actually smaller numbers, but they're much farther from 0. So this is a little bit trickier in terms of the numbers we're using, but you can do the same thing. Find your center, find your distance from center. Where's our center going to be? It's in the center. What number? -9 is the center. Now, you can actually find your center by counting in, but there are some things that could trip you up. Like, for example, your center might be a decimal, or the number line might just be really, really big. Like if I ask you to find the center between like 100 and 5,000,002. Like you don't want to have to count that in, right? So we need another way to find the center for when it's tricky. And this is to find the average. So the center can be the average. That's when you add the endpoints together and divide by 2, because you had 2 numbers that you're averaging. So that's going to give me -18 over 2, which is -9. So I got the same thing you guys got by counting out. After you find the center, you want to find the distance from the center. So again, some of you counted from the center, and you counted all the way to the endpoint, and you got what distance? 8, yes. The other way you can find the distance is just by subtracting. So you can find the distance by doing -1 minus -9. Ryan, when we do minus negative, what does that make? Say it again. Positive, right? Guys, remember when you have minus negative, that makes a plus. So we get 8 from this as well. I'm going to still use x minus center equals the distance from the center. So it'd be x minus -9 equals 8. Now for some of you, I saw x minus 9 on your paper. And remember, x minus -9 doesn't mean the same thing as x minus 9. Because when you have 2 minuses, it makes a what? It makes a positive, okay? So after we write this, we're going to simplify the minus negative to be a plus. And then if you look back, it says there is addition. That's where the addition came from. It comes from when you have minus negative. Whenever you have a minus negative in your equation, it's going to make a plus. All right. So It says, using these examples, explain how to write an absolute value equation given two solutions. So here's where you're going to write some words. You can tell them first do this, and then do that. You're going to write the words for how to find the absolute value equation if I tell you the two solutions. I want you to go ahead and do that now. Step 1. What did I find first in this problem? The center. So step 1 is find the center. You can count it out or you can average the two endpoints. So find the center. Step 2, find the what? Find the distance from the center. Good. Find from the center. And then step 3, we're going to use that equation, absolute value of x minus center equals distance. Okay. Find an absolute value inequality with a given solution set. So, remember that on the warm-up, we had a picture like this. It was going out, and that was because Armando described what a greater than would look like. If your distance is greater than a certain number, it's going to be going out. So this would be a greater than. Which is this. And then on your number line, if you are between two numbers, that would be a less than. Because you are less than a certain distance away. So if you're close, it would be between, and that's a less than. If you're far away, that's going to be going out, that's a greater than. Okay? So this one we can see is which one? Greater or less? It's a less because it's between the two numbers. So we're going to be using that less than symbol. So we're going to be doing absolute value of x minus the center is less than the distance from the center. So you still need to find the center and the distance. So go ahead and do that. And the only thing that's changed is that instead of equals, we have a less than right there. Okay? All right. Some of you are finding the center by counting in. That is totally legit and that's fine. However, I do want you to consider having somewhere in your notes another way to find center for when that's not working, and that is to average the endpoints. Okay? So, just in case counting in doesn't work for you sometime, write this in your notes. You're going to add the -3 and the 7 and divide by 2 to find the average, and you get a center of 2, which is what most of you found when you counted it. That's good. The distance, you can count it out, but you can also subtract. So your distance is going to be the endpoint on the right side minus the center. So in this case, 5. And it's the same thing you should get from counting. And then we can use this sentence frame here. Absolute value x minus 2, because that's your center, is less than the distance. And that should go in a box. Just this. After you do this, you write it out twice to check it. I saw a lot of you guys did that work to check. All of that work is a check. This one is your actual answer. Okay. So in this one, it looks different, but looking back at our notes, we realize the only thing that's different is that it's going to be the greater than, and because the dots are filled in, it's going to be greater than or what? Or equal to, good. Because the dots are filled in, and then greater than because it's going out. Your center is right here in the middle. If you saw it was in the middle and you just said the center is 4, that's fine. But if you wanted to, you could add them together, 3 and 5, and divide by 2, and you would also get 4. The distance from the center, again, you can look at it and say, okay, it's just 1 away, so the distance is 1. Or you can subtract 5 minus 4 and get a distance of 1. So either of those is fine. So then we're going to write your answer out. Absolute value of x minus the center is equal to the distance? No, it's greater than or equal to the distance. If you have this on your paper, box it up so you don't lose it among everything else, because that is your solution. Did you get something different? Let me know what questions you have.
Wait, I got X. I just got that as like my final answer.
This is the final answer.
Oh, okay.
So some people did more work to check it, and that's totally good. But this is the actual answer.
Wait, so if you add it, would it be X greater than 5?
Yeah, that's this part here. And then you would do the other one where you make it less than -1. Yeah. And that would give you x is less than or equal to 3. No, the distance is 1 because here's the center, it's at 4, and the endpoint is 1 away from that. All right, the next one, the equations look different from what we were expecting, but we're going to first figure out what answer we want it to be, and then we'll see what matches up with that. So, your center. Looking at the points, I can count in and see that my center is -4. My distance from the center is 3.
He's definitely letting out a stinky shit.
Okay, so I have a center of -4. I have a distance of 3. Is it a less than or a greater than?
Less than.
It's a less than, good, because it's in between. So the answer I was hoping to see is the absolute value of x minus -4 equals 3. No, not equals. It should be less than. That's what AB just told me. Less than 3. But minus -4 is going to make what? Yeah, so I was hoping to see absolute value of x plus 4 is less than 3. But I don't see that over here, but I know one of these equations is going to match up with that. All right, so Cassandra and Leslie had a shortcut for us. They got rid of 2 of these answers. Cassandra, which 2 can we get rid of?
B and C.
All right, do you guys see how we can get rid of those middle 2 answers there? Because they don't have a less than, they have a what? A greater than. So because of the greater than here and the greater than here, we can eliminate those 2. So we just have to look at 1 and 4. Those are Roman numerals for 1 and 4. Which one should we check first? You guys want to check 1 or 4 first? Check 1. Okay. So for 1, here's my absolute value of x plus 4. How do I get it by itself? How do I get rid of this plus 5? How do I get rid of a plus 5? Minus 5, right? So if I minus 5 here and I minus 5 here, then this one would become x, absolute value of x plus 4 is less than -2 minus 5, which is -7. Is that what we wanted? No, let's try the other one. So here's a minus 5. I'm going to plus 5. What's that going to give me? It gives me 3. So this one goes to absolute value of x plus 4 is less than 3, which is what we wanted it to be. And so this would be our answer. All right, so we kind of had to work both directions on that problem. We had to work from the number line to get what we wanted it to be, and then we had to look at the answers and see which one matched it. Please make sure you've worked through that problem. You are going to need to know how to do problems that are that tricky. I'm going to wait a second to see if you have a question. All right, so looking at C, some of you guys are trying to make some sense of what this was. This is interval notation, and it's representing a solution set in a different way than on a number line. And so one way to make sense of that is to do what Osmond did, which is to make a number line out of it. So if you make a number line, like this, then I'm going to mark 4, and I'm going to mark 16. And then do I have open dots or closed dots at 4 and 16? Yeah, I have open dots because it has a parentheses, which means not including that number. So this side goes to negative infinity. And then this side goes to positive infinity. And then once you change your interval notation to a number line, you can see that this actually does look like a problem we've done before, right? All right, now I don't have all the little lines in between to count my center, so I'm going to suggest that you guys find the center by averaging those numbers. So for the center, let's average 4 and 16. And then once you find that, you can find the distance by subtracting. All right, so go ahead if you haven't yet, find that one. If you have done that, you can work on the other problems on this page. All right, I'm going to finish up C, and I'm going to start talking about 1 in the review section. So in C, first we found the center by averaging these two, and you should get 10. And then for the distance, I'm going to do 16, my endpoint, minus 10, my center point, to get a distance of 6 from the center. So it's x minus the center. Is this going to be a less than or a greater than when it goes out? Is that less than or greater than? It's greater because you are a farther distance away. So greater than, and then my distance 6. Okay. All right, guys. In the review problems, what we have to do is we have to start by getting that absolute value by itself. A lot of people started this by trying to add the 5 and the 2, but we can't do that because the 2 is stuck on the absolute value. So what we do want to do is get rid of the 5 on both sides, and it's being added, so we're going to get rid of it by subtracting. So start by subtracting 5 on both sides.
I go to the bathroom.
And then, if those were parentheses, we would distribute. But because it's absolute value, we do not distribute. So how can we then undo multiply by 2? Jeffrey? Division, very good. So we're going to divide both sides by 2. Now, when we're here, this is when we're going to write two different equations. It's not going to be 13 and negative 13. It's going to be 4 and negative 4. You don't take the opposite until you have the absolute value all by itself. So one of the equations is x plus 3 equals 4, and the other is x plus 3 equals negative 4. Question?
Why did you, wait, never mind.
Okay. If you decide you do have one, let me know. All right, and then we can solve each of these. So I'm going to subtract the 3, and I get x equals 1. And I'm going to add the 3. No, I'm not. I'm going to subtract the 3 again. I was like, what am I doing wrong? It's still a plus 3, so I still subtract the 3. And I get x equals negative 7. So those are my two answers to this problem. You need two answers. Questions on that one? All right. This problem is like last class when we did a word problem. Go ahead.
Is it both for minus 3? Or is one plus 3?
They're both minus 3. Yeah, it was a plus 3, so we subtracted 3 on both sides. For some reason, I don't know. I wasn't thinking straight, but I got it. Okay, so this was from last class. This is a day 2 problem. A 12-ounce bag of chips can vary up to 0.2 ounces, more or less. So that means it can be 0.2 ounces more, it can be 0.2 ounces less. It could be like 0.1 ounces more or less. It can't be any more than 0.2 ounces away though. So to write the absolute value inequality and then solve it. So we haven't been solving much today, okay? So we're gonna write and then we're gonna solve. We're still gonna use x minus the center, absolute value, and then equals the distance, except of course it's not equals, it's what? Good guess. Yeah, because it has to be between these two values, it's going to be a less than or equal to. Okay, so my center is what you would expect the weight to be. What do you expect the weight to be? 12 ounces, good. And then the distance is how far away from 12 we can be. How many ounces away from 12 can we be? 0.02. Okay, so 12 is your center, 0.02 is your distance from the center. This is one of the answers, that's for right, but now I have to actually solve it too. So when I solve it, I write it a second time, x minus 12, and then instead of a less than, I put what? Greater than or equal, and then negative 0.2. Solve each of them with a plus 12. So I have x is less than or equal to 12.2. X is greater than or equal to 11.8. And whenever you have one of these problems where you're between two numbers, you need to express it with the x in the middle. So I'm trying to like make some space, steal some space from this problem over here. So the smaller number comes first, the 11.8, less than or equal to the x, less than or equal to the 12.2, like that. All right, once you have that one done, I want you to try 3A. You're going to try that on your own before we go over it. Okay. So we have to get rid of the minus 2 first. So whenever there's something to add or subtract, that's what we're going to get rid of first. So I have to add 2 on both sides. So I have negative 5 absolute value 2x plus 1 greater than or equal to negative 10. Now I have a negative 5 that is multiplied by that absolute value. How do I undo multiplication? Division. So I'm going to divide both sides by negative 5. Absolute value 2x plus 1. That gives me a positive 2. And when I divide by a negative on both sides, what do I do to my inequality? Yeah, you flip the inequality when you divide by a negative on both sides. So this is my isolated inequality. So now I need to write it out twice. 2x plus 1 is less than or equal to 2. 2x plus 1 greater than or equal to negative 2. Once you have it by itself, you can write it 2 times. And then you're going to solve. You're going to subtract the 1 and divide the 2. So you can leave this as 1/2. I do like to make it a decimal because it's easier to put on a number line when it's a decimal. 2x is greater than or equal to negative 3. Divide by 2. And x is greater than or equal to negative 1.5. So over here, I need to think about this on a number line. So I'm going to move my work over a little bit. Okay. So on the number line, I need these numbers. Negative 1.5 and 0.5. So I'm going to be less than or equal to this number, goes that way. And I'm going to be greater than or equal to this number, which goes that way. So it's going to be the numbers in between these two. So that's my number line representation. And then set notation is when you put the x in the middle. So negative 1.5 is less than or equal to x, which is less than or equal to 0.5. Interval notation is when you put a comma in between the two numbers. And should I be putting parentheses or square brackets on that? Look at the dots. The dots are filled in. Does that mean parentheses or square brackets? Square brackets. All right, that was a lot.